Follow up to the Intro to Functions gizmo that you all completed in class. Um, it relates back to the main three words that we need to talk about, which are domain, range, and functions. So we're going to start with what a relation is. A relation is just a more general terminology. A relation just means you're relating input and output values. Now, we've seen this a ton this year already. Ordered pairs relate input and output values. Your input and output values, which you should be filling in information on your notes, but your input and output values, we've seen X and Y, we've seen graphs, we've seen tables, we've seen sets of ordered pairs. The only thing we haven't really seen is mapping diagrams, and they're really just a good visual to help us with our understanding of domain and range. So that takes us right into what you guys saw in the gizmo was definitions for domain. Domain was, or is, all possible input values. This is just a description of all the values that can be, and possible is important here. It's a description of all the possible values that are used, could be used as inputs. Now, domain and the word input and the value or the variable x and independent variable, all of these are saying the exact same, we're talking about the same quantity. So you may want to have some flexibility. You're going to need some flexibility in your thinking when you're talking about these input and outputs, domain, x, independent variable, realizing they're all talking about the same thing. The range is just the listing, the description of all the possible output values. Now, range does have meaning in statistics, talking about variability, talking about the spread of data. But this is a different use of the same word. So the range would be the y value, would be the dependent variable. So domain and range, we will do, I guess I misspelled that. We will do more with domain and range going forward, but it's a good place to start here with thinking of that idea of all of my possible values listed out. Now, thinking about those inputs and outputs, and we'll get to the definition of function in just a second, but a function is taking those inputs and outputs, and there's a special type of relationship that exists. That functional relationship works a lot like how a functioning, I should say a functioning machine, which receives inputs and creates outputs. So we did the activity yesterday, which we talked about how some of the questions were like functions and some of the questions weren't, depending on how you placed yourself A, B, C, or D. But then I wanted to bring another example in, which is a vending machine. And so I'll talk about that in just a second once we get the definition of a function. So what is a function? What you guys saw in the gizmo is a function is a relation in which each domain value has, and this is the important part, exactly one range value. Every item in the domain, every input has exactly one output. So you can use, notice each of those words, input X, output Y. Every one of the domain values has exactly one range value. Every input has one output. So how this works like a machine, and this is my little machine here, is if you imagine that there is an input. Let's pretend this is a vending machine. So you're pressing the button. You're pressing the vending code machine. Let's say you press A5. You press A5, and out of the machine comes a candy bar. If you go back and press A5 again, what do you expect to get? A candy bar. You press A5 again, you expect to get a candy bar. That's a functioning machine. I go press B3, and maybe I get out instead a soda. I go press B3 again, I'm going to get a soda. Now, what would be a non-functioning machine? Would be I press A5, first time I get a candy bar, the second time I get a soda. So these are my inputs. And if you look at have the mapping diagram kind of picture in your head, and this is the outputs. If I asked an input of A5, according to what I've found out from my vending machine here, I have an output of candy bars sometimes and an output of sodas other times. That is not a functional relationship. Every input is going to have a single output. Now, could I have a third code, C7, that also gives me soda? That's still possible. Maybe the soda is really popular, so they put it in multiple slots in the vending machine. So with the vending machine idea and the questions are just meant to kind of help give you a more concrete example of what a function is, but let's talk about what they are in aspects that you're going to be required to do. Oh, sorry, the phrasing, I meant to click this. The phrasing of y is a function of x, you'll hear that a lot when you talk about functions and linking input and output values. And what that just means is that the function, so is a function of, it's saying that the y value is the output that is determined by whatever your x value was. So the output's related to what the input was. And that you'll hear that phrasing a lot. So what is a function? We're going to look at 3 different situations here, and all of them are related, but you want to keep that in mind, that definition of function. Each input has one output. So if I look at this first example, and I'm going to go back to the mapping diagram. If I list out my inputs here, 1, 2, 4, and 5, for it to be a function, and I'll list my outputs here. I have 3, 9, and 5. For it to be a function, each input maps to only one output. So 1, 3, 2, 3, 4, 9, and 5, 5. This would be considered to be a functional relationship. Why? Because each input, and you need to write these points. You don't have to do the mapping diagram, but you need the reason here. Each input has one output. Now for the second group, that popped up here. For the second group, this is not a function. Let's look at the mapping diagram for this. We have 1 and 3 that are in the domain. They're repeated there. And then we have 2, I'm trying to go in order, 2, 4, 5, and 6 in our outputs. So 1 maps to 2, 3 maps to 5, 1 also maps to 4, and 3 also maps to 6. You can always ask yourself here, if you have an input of 1, what is the output? If you have more than one answer, that is not an example of a function. So for this not a function, we'll just give the example of, for the inputs of 1 and 3, each have more than one output. Like you want to identify the case here because we have specific numbers. Oops. Sorry, skipped ahead. You want to identify the specific numbers that are causing you the problem case, is what the gizmo referred to it as. But 1 and 3 are the problem case that cause us to not have a function here, because those inputs each have more than one output. And the mapping diagram you can see is a little bit helpful with this. Okay, what is a function from a graph? So this has to do with the vertical line test. So I'm going to start with not a function, and I'm just going to put points. But what you saw on the gizmo was if you were looking at a vertical line. Vertical line test, you could either, I'm going to actually start with pass, or you could fail the vertical line test, and that told you whether it was a function. Oh my gosh, sorry, I keep pressing buttons that I don't need to. It could either pass, which means it's a function, or it could fail, which means it's not a function. I'm going to erase that. Not a function. oh, sorry, computer issues. So when we're talking about the vertical line test and failing it meant that I could draw, and a vertical line is only up and down, no diagonal portion to it, it's only straight up and down. Why is this not a function? So fail means you can draw a vertical line through 2 points, or through at least 2 points actually. Draw a vertical line through at least 2 points. Why this tells you that it's not a function. Let's look at the example we have here. Let's give these points names. Let's say this is 3, 1, and let's say this is 3, 5. Didn't even press it that time. Why is this not a function? Why is drawing the 2 points through the, or why is drawing the vertical line through the 2 points important? Because look at what a vertical line has. So all points on the vertical line, what do they have in common? They all have in common the same input. All points on the line have same input. So if you're hitting more than 1 point with that vertical line, you're hitting more than 1 point with that vertical line, that means you have multiple outputs. So these 2 points both share 3 as the input. If I think about my diagram, they have 2 different, because there's 2 different points, they have 2 different outcomes. Oh my gosh, I'm sorry. This is technology issue. Passing means that if you draw the vertical line, your vertical line only hits a single point at any one spot. So passing means vertical line hits only 1 point at a time. So you're only hitting 1 point at a time. That's telling you that every input has exactly 1 output. We'll talk more about this and we'll do some more examples together. But the last piece here to finish off, what is a function from an equation? I have 2 examples of equations that are functions. And basically what it comes down to is, think about the idea again. X is your input, Y is your output. If I take a single input into either of these equations, so let's say I said X is 3. In the first equation, if X is 3, I plug this in. I do 3 times 3 plus 5 is 14. Y is 14. For this to be a function, every time I plug in a number, I get 1 number out. I plug in 3 again. Do you think I'm going to get a different number out? So 3 squared is 9. 18 minus 1, this is Y is 17. Sorry, I keep having technical difficulties. But for both examples here in our equations, we plug in a number. There's no reason to think we would get a different value out for Y a second time around. Plug in 3, there's no numbers I could plug in where I plug in one value and then sometimes I get Y as one value and sometimes I get Y as another. For it to be not a function, this is a very special case. We're going to plug in, again, we're plugging into X. Let's say that X is 16. If Y squared is 16, our output is the values that make this true. Well, what squared is 16? It could be 4, or there is a second value. This would be negative 4. So why is this equation itself not a function? Not a function because for single input, for input of X equals 16, there are 2 outputs. And there just has to be one example of it. There doesn't have to be, but there are 2 outputs associated with it. For the function examples, for every input, there's only 1 output. And that would be true for most equations that we look at, except for a few select special cases.